All right, coming at you with our last video of the year, page 8 of our final exam review. In some ways, one of the tougher topics, but in some ways not actually as bad once you kind of get into it. So let's take it from scratch here. So keep in mind, this thing is sitting in what we call trig notation, because notice we have trig there. And a lot of times we choose to write this as CIS. We talk a lot about cis notation. But the question is, can we go from this cis notation and get to A plus BI? Or, like this problem, can we start with A plus BI and get over here to cis? And it's the same idea, just different representations. Now, this one is unit circle. Pi over 4 should be a big fat hint. This one is not unit circle because it's not like two numbers that are the same or a number with a number root 3. So we're going to have to go ahead and use a calculator on this one, but we do not need a calculator on this one. So this one is as simple as the fact that we should know, based on our understanding of the unit circle, that the cosine of any kind of pi over 6 is root 2 over 2, as is the sine of any kind of pi over 6. And then we have to stop and think what quadrant it is in. And pi over 4 is just in the first quadrant. It literally is just 45 degrees up in that first quadrant, where both the cosine and the sine are both positive. Quick distributive property, 12 times this, the 2's would cancel, and I get 6 roots of 2 and 6 roots of 2i. That is in my A plus BI form. I'm done. There's nothing more to do with that problem. Now, this next one that we're going to have to do is we're going to have to look at it a little bit and think a little bit through the Pythagorean theorem. And I need to find out what the radius is, which I did talk in class about how that's actually known as a modulus. So we're going to go to the right 6. We're going to go down 3i. Keep in mind that 6 squared is 36. Again, 3, not 3i. Just think about the value of the distance down, which is 3. 6 squared and 3 squared, that would be 36, and 9 makes 45. That makes the modulus root 45. Now, I'm going to do a little bit better than that in a second, but I'm going to leave that modulus for the moment as root 45. I needed to grab a calculator here. And, we've talked a lot about how I prefer radians, and some of you guys may not. But again, all I'm going to do is to my apps thing, remember second angle. I'm going to go to number 6, and I'm going to tell my calculator to go to the right 6, just like I did, and comma, go down 3. Remember, you don't put the I in because your calculator would get very confused if you put that in. And according to that, we would go down 0.463 radians. Now, that is pretty good, but there's one tiny thing that we could do because, again, this isn't a basic math class. We want to be a little bit more precise. 45 is 9 times 5. I think everybody knows that, but we know that the square root of 9 is 3. So we could call this 3 roots of 5, CIS, negative 4.63. And we got it. We got the radius, we got the angle, we're done. Now, moving into a little bit closer to what we call Demobras Theorem. And Demobras Theorem says if you ever take any of these values in this trig form and you want to multiply them, then literally all we need to do is take the angles and multiply them together. So, the radii, 18 times 6, multiply them together, I got 108. So this is 108 CIS. If I take 72 and I take 50 and I add them together, I'd have 122. Now notice it says let's answer in both trig form and A plus BI form. So we're going to need to do that. So we got the trig form down. Let's do this one too. Well, when we divide, we literally divide the modulus or the radius, which gives me 3. And then just like the previous one, but instead of adding, we're going to subtract. So I'd have 22 degrees. So very, very simple values. But again, if we want to go ahead and get it into the A plus BI form, I must first be in the proper mode. This problem was given in degrees, so I have to do that. And so all I need to do is take 108 cosine of 122, and I've got negative 57.231. And then I need to do 108 sine 122. And I got plus 91.589, pi. And similarly over here, 3 cosine of 22 is looking at 2.781. And if I did 3 sine of 22, I would be looking at 1.124 plus 1.124i. So this is in the trig form that it asked for, and this is the a plus bi form that it asked for, and I'm actually done. So now to the big finish. So what we're asking for in this thing is to take this guy right here, which we already did up top, the 6 minus 3i, and find the square roots of it, as well as raising this to a power. So very different looking problems. So if I were going to go to the right 2 and down 2i, this is a special right triangle with a radius or modulus of 2 roots of 2. That is clearly a 45-degree angle, or a pi over 4 rotating down. So I would start by thinking of this as a 2 root 2 modulus. I personally really like the CIS notation rather than writing it all out, and I have to assign an angle. Now, Demobras theorem says if you ever, and that's what I'm going to do for both of these problems down here, if you ever have a problem in this form, all you have to do to raise it to an exponent of any kind is take the radius to that exponent and then assign the angle that you had, but multiply that angle by that particular exponent. So in this case, we're taking z to the 5th. So that means take our modulus to the 5th. And then let's take that angle and multiply it by 5. Now, this is actually a good answer. It's a pretty good answer. It's not too bad. I need to figure something out about 2 roots of 2 raised to the 5th power. There's a little bit of a reason why, but if you write all of those things down, you get a whole lot of 2's, a whole lot of root 2's. They kind of partner up. You end up with 128 with a root 2 left over because I have 5 root 2's. And keep in mind, if you have 1, 2, 3, 4, 5 root 2's, these two make a 2, those two make a 2, but we had an extra one left over. That's kind of what's going down. And last, negative 5 pi over 4 is in the second quadrant, where the cosine is negative, but the sine is positive, because keep in mind, cis stands for cosine theta plus I sine theta. This one is negative, that one's positive, and I end up with negative 128 plus 128i. And that's literally all there is to that problem. If you distribute these, all of those root 2's kind of cancel out, and it just comes out pretty nice. Okay, now my last problem, which is that we're going to look at the square roots of this crazy thing right here. So keep in mind, my original problem that I wrote above was 3 roots of 5, CIS, negative 0.463. It looks like I made a typo above, 0.463, not 4.63. Let's fix that. Let's make it 0.463. And so the Demobras theorem says if we're going to raise it to the 1/2 power, then I'm going to take the square root of 3/5, because I'm going to take 3 roots of 5, and I'm also going to raise it to the 1/2 power. And then I'm going to take this angle right here, this 0.463, which honestly, I kind of wish I still had in here, but I think I can go back and get it. I had it somewhere back here. There it was. Except I think I did it in radians. So let's try that one more time. So this negative 0.463 number that I had, and let's divide it by 2, because remember, the thing says multiply it by that thing, which was 1/2. So now it's negative 0.2318. So we're pretty much good to go. And this is my first answer. But my second answer means I have square roots, so there should be 2 of them. So if I could rotate exactly 2 pi over 2 to distribute 2 answers across the full circle 2 pi, I just need to rotate pi, which is kind of interesting. So if I could take this answer, which I'm going to store here because I'm going to use it in a second, but if I could add pi to that based on this rotation, I have another answer, which is the square root of 3/5 CIS 2.907. Now, again, that's a really strange number, but let's just see what happens. And I'm going to store this one as alpha b just so I have it, okay? So let's see, 3 root 5, okay? Now let's go ahead and take the square root of that. Okay, so I got 2.59, okay? And what I'm going to do is I'm going to take that 2.59 and I'm going to multiply it by the cosine of A. And then I'm going to do plus, hopefully this is going to work out okay. I'm going to also take that answer that I had times the sine of A. But I want to put an I on it so it doesn't accidentally put those two things together. And I got 2.521 minus 0.595I. Now, we will say that's a strange looking answer, but in theory, if I square that thing, if I've done it right, if I square it, I should get 6 minus 3I back, and I did, which is really still blows me away to this day. So again, we're going to do that same thing down here, and we're going to take that 3 roots of 5. We're going to take the square root of that value, boom, 2.59 again, just like we had before. But I'm going to multiply that by the cosine of what I stored as b, plus I sine of b, I times the answer, because I had to distribute, times the sine of b. And hopefully this makes sense pretty good. And so my other answer, not surprisingly, is going to be almost the same answer that I had a minute ago. Notice it looks the same, and it should because they're exactly pi or 180 units apart. So they should just be across from each other on the unit circle. And hey, we finished trigonometry. It's all done. Done for the year. I'll see you back in class, and hopefully I'll see you next year too. Okay, bye.